This was a test over exponential and logarithmic functions. I'd made 3 reviews on previous videos, day 14, day 13, and day 12. So I'm going to go pretty fast on this video. If I move too fast, talk too fast, I mean, you can play it over and over again, but the other videos I made, because they were reviews, I went considerably more slowly. But this will be fast. Put down your pencil. No pencils. Watch me do it. Learn how to do it. But then make sure you can do every problem by yourself. No pencils. Don't forget that this is an invisible base 10. One way to do this is to ignore the 1 for a moment. So then I've got base 10. You ask yourself, 10 to the what power is going to give you 10,000? Whoa. Yeah, 10,000. Well, that's 4 zeros, so that means this would be 10 to the 4th power. So at first you're thinking 4, but then you remember, oh yeah, it's really 1 over. So that means it would have to be a negative 4 to drop you down. Number 2. Same thing. Cover up the 1 for a minute. Ask yourself, 7 to the what power is going to give you 343? Pretty sure that's the 3rd power, but we can look at the table. 7 to the 3rd power is 343. So for a minute there you're thinking, okay, 3. But then you remember that you covered up the 1. So this would really have to be a negative 3 to drop you down. Okay, number 3. Same thing. 6 to the what power, this is what you're thinking. 6 to the what power is equal to 1,296. I don't know. I'm going to look at the table. Let's see. Boom. 4th power. So the answer is 4. We didn't cover up any 1 or anything, so the answer is simply 4. Number 4. I'm thinking 9 to the what power equals 1? Well, that's 0. Anything to the 0 power is 1. Number 5. Oh no, I'm thinking 81 to the what power equals 3? But I've got a big number going to a smaller number. That means it must be some kind of a root. Some sort of a root of 81 is equal to 3. But what root? Square root, 3rd root, 4th root? Let's look at the table. Look for the 3 and the 81 on the table. Well, there's my 3, there's my 81. Oh, that's 4th power. That means the 4th root of 81 is 3, 4th root. Okay, alright. So if this is a 4th root, that would work. But 4th root is the same thing as the 1/4 power. So there you go. Number 6. Oh, same thing. Big number becoming a smaller number. That means it must be some sort of a root that gives you this 5. But what root is it? Is it the cube root? Square root? 4th root? Let's check. There's 5. There's 125. That's a 3. That means the 3rd root of 125 is 5. Whoa, too much. Okay, that tells me this is the 3rd root. But the 3rd root is the same thing as the 1/3 power. So there you go. Yeah, anyway, number 7. Oh, I have this x sitting here, so I'm going to do this a different way. I'm going to do it a different way, y'all. Here's how I'm going to do it. I've got log base 2. 16 is 2 to the 4th power. And that x, I'm just going to put it right next to the 4. 16, I claim that's 2 to the 4th power, but don't take my word for it. 2 to the 4th power is 16. When you have a log base 2 and a base 2, these cancel each other out. So the answer is just going to be 4x. Not just 4, 4x. Oh look, again with the invisible base 10. You ask yourself, 10 to the what power is equal to 1,000? Count the zeros. That's 3 zeros. That means 10 to the 3rd power is equal to 1,000. The answer is 3. Okay, 7, 8. I would have thought 9 was right there, but it's not. Oh, look, it's down here. Which of the following is equivalent to this mess right here? Well, without even looking at this stuff, I would just expand this in the first place. Like a gentleman, okay? Like a boss. So, expanding. So, look, when I look at this, I see 1, 2, 3 things. Alright, now keep in mind that this one on the bottom is like having x to the 1/2 power. So I'm going to make 3 different log terms. So that would be like this. Everything in the top is going to be a positive term. So I've got log base 4 of 16. That's positive. This is going to be positive. So plus log base 4 of y to the 4th power. Now this one in the bottom is going to be minus. Anything that comes from the denominator is going to give you a negative term. So this is going to be minus log base 4 of x to the 1/2 power. Change the square root to the 1/2 power. Now, anything with an exponent is going to go in front. Also, I recognize this can be a whole number. 4 to the what power is 16? That's 4 squared. So this whole term is just has a value of 2. Putting this in the front, I have 4 log base 4 of y minus. This 1/2 goes in the front. So 1/2 log base 4 of x. So that is what I would get if I expanded this. Now, does anybody see that anywhere? Nothing over here. Nothing over here. Oh, wait a minute. Is this it? Oh, well, you look at that. A is exactly what I had over there. 2 plus 4 log base 4 of y minus 1/2 log, but yeah, same thing. So A is the answer. Number 10. Oh, now we're going the other way. We're condensing. Anything with a power, any coefficient is going to jump over here and become the power. Okay. Alright, when I was a kid, there was this song called I've Got the Power. So every time I hear the word power, secretly in my mind, I'm thinking, I've got the power. Look it up. You'll thank me. Anyway, this will be log base 2 x to the 9th power. Alright, I just put that up there. Now I'm condensing, so I'm going to break this down to a single log. So this will become log base 2. This one will go in the top, this one will go in the bottom. So I will have 9 over x to the 9th power. That seems to be this right here. Log base 2. Yep, look at it. Genius. So yeah, the answer is E. Alright, where's number 11? Paging Dr. 11. Alright, which of the following is not correct? I'm looking for one that's false. Now, when I condense, I multiply. Oh, well, it looks like this one's false right away. If I condense these, this should have been the same thing as log base 2 of 3 times 12. Okay, that should have given me 36, not 15. You don't add them. So A is the one that's not correct. Okay, number 12. Which of the following is equivalent to, okay, so they're just begging us to work it out. So here we go. 0.25 is the same thing as the 1/4, base of 1/4. So I've got log base 1/4 of 16. Again, an easy thing to do is to cover up the 1 for a minute and go ahead and ask yourself, 4 to what power is going to give me 16? Alright, well, that's 4 squared is 16. So for a minute, you're thinking 2. But then you remember that you covered up this 1. Alright, so this is really 1/4. So to make that equal 16, it needs to be a negative 2. Kabam! And so that's why the answer is C. C, senor. Okay, number 13. Find the value of a in this expression. Well, when you're finding the value of a variable, most often it helps to write it in the other form. So I'm going to write this in exponent form. And when I do that, I start with the base. The base is a, y'all. Everything else is going to switch sides. In exponent form, there is no log anymore. Gone. So I have my a, and these switch sides. So it'll be like a to the negative 2 power, and then equals 9. If I want to get rid of that negative 2 power, my recommendation to you is to do the reciprocal. So I'm going to do negative 1/2 power. Of course, I have to do it to both sides. Negative 1/2 power. Okay, now on this side, a negative 2 and a negative 1/2 being reciprocals and all, these just cancel each other out. So that's just going to leave me with a. So all I have to do is simplify this. Now, a negative power always drops you down. So I've got 1 over 9 to the 1/2 power. So I've got 1 over. Now, 9 to the 1/2 power is the same thing as square root of 9. Square root of 9 is 3. So in the end, I've got 1/3. Let's hunt for it. Oh, bam. The answer is E. Okay, number 14. If you have a pencil in your hand, I need to remind you, put it down. Do these problems yourself after I'm done. Okay, alright. Find the inverse of each function below. You got to show your work, people. Got to show your work. Okay? Oh, by the way, that definitely includes number 17. If you don't show your work, you get squat. Alright? I think the answer is 9. But if you don't show your work, 0, my friends. 0. Alright, anyway, this here is really like a y. Alright, there are two main steps of finding the inverse. You switch x and y, and then you solve for y. So first we switch x and y. Okay, so this will become x equals log base 7 of y plus 6. See what I did there? I switched x and y. Now I got to solve for y. Well, there's the only way to get this y out of a log is to rewrite this in exponent form. So there's my equal sign. Base, how low can you go? That's another song. I think that was Public Enemy. Yeah, y'all kids today, you don't know. You don't even know. Look it up, Public Enemy. No, actually, you know what? Don't look it up because it's not appropriate. Alright, parents, let the record reflect. I changed my mind and I told your kids not to look it up. So if they do, that's on them. Do not like sue me or whatever. Anyway, got to get this y by itself. So minus 6 on both sides. Yeah, so that's the answer right there. Got y by itself. You have to put the f back in there, so that's going to be f inverse is equal to 7 to the x power minus 6. So that's number 14 right there. Number 15. Again, this is like a y. Switch x and y, solve for y. Those are the two main steps. So here I'm switching x and y. So I've got 2, 3 to the y minus 1 power. Now, eventually I'm going to put this in log form. Okay? The last problem, I started in log form, so I ended up with exponent form. On this problem, I'm starting with exponent form, so guess what? I'm going to end up with log form. But before I do that, first you have to get this base and power alone by itself. Yeah, of course, that was a little redundant. Anyway, so I need to add 1 to both sides. So that's going to give me x plus 1 is equal to 2 times 3 to the y power. Okay, I still need to get this part by itself. So now I'm going to divide both sides by 2, like that. So that'll give me x plus 1 over 2 is equal to 3 to the y power. Now that I have the base and power by itself, now I can rewrite this in log form. Now I'm still going to start with the base. Log form obviously involves the log, and it goes log base 3, like that. Make sure your 3 is low. See how it hangs low? If this is the line of the log, the 3 should be down. So anyway, the x plus 1 over 2 and the y, they're going to switch places. So the y is going to be over here. Okay, the x plus 1 over 2 is going to be here on the line with the log. So that's the answer right there. So that means, I'm going to put it on the line properly. Was this f again, or is it like a g? This time it's g. Okay, so that's going to be g inverse is equal to log base 3 of x plus 1 over 2. Alright, do not put this x plus 1 up high like it's some kind of an exponent. I will mark that wrong faster than you can say be helpful, not hurtful. See, 7 to the x power minus 6. F inverse is equal to 7 to the x power minus 6. Yeah, that's right. I said it. Be helpful, not hurtful. That's what I always say. Alright, which one was that? Alright, number 16. Again, this is like y equals. So when I switch the x and y, I will get x equals natural log y minus 4 plus 3. This is log form, so ultimately I will be in exponent form. But first, you have to get the log expression by itself. So I need to subtract 3 from both sides. So that'll give me x minus 3 equals natural log y minus 4. Now, please remember that natural log means an invisible base e. Okay, so now that the log expression is by itself, I can go ahead and rewrite this in exponent form. Start with the base. So there's my equal sign. I'm going to bring down my base, my e. Okay, now the x minus 3 and the y plus 4 are going to switch sides of the equation. Okay, so the y minus 4 is going to be over here. Now the x minus 3 is going to be over here, but this is not log form anymore. This is exponent form. So this x minus 3 now should be up high because now it is an exponent. This is not quite finished. I need to add 4 to both sides. Okay, just stick it on the end here. And so that means the final answer, this was an h, so the final answer is h inverse is equal to e to the x minus 3 power plus 4, like that. Okay, number 17. Alright. Number 17. This was the most commonly skipped problem. But this is one of those problems that separates the A's from the B's. Alright, you can get a B easily without this problem. But if you want the A, gotta be able to do stuff like this. I'm sorry. That's the way it is. The way it is. Now, here's how I like to do it. I'm going to use some substitution. So first of all, I'm going to call this part, like everything I just colored in yellow, I'm going to call that Q. Okay? So let me make that substitution. You know why? Because I can. Alright? And I like to do it in stages. So first I'm going to solve for Q. Yeah, remember that this is an invisible base 10. Let me pink it in. So this is an invisible base 10. So if I rewrite this in exponent form, then you know, the 10 comes down, the q and the 0 switch places, so I have 10 to the 0 power is equal to q. Okay, that means 1 is equal to q, because anything to the 0 power is 1. So now I know q is 1. Alright, so next I start with that. Alright, I just bring this back up here. So q is equal to 1. Okay, so now look and see, what did I say was q? Everything here in yellow. So now I'm going to make that substitution. I'm going to replace q with the yellow stuff, because that's what it is. So that means log base 2 of log base 3 of x. Alright, that's q. And q equals 1, like I said. So I've got this right now. Okay? And I could do this all day. If you gave me a string of these, like 15 logs long, I could just do one piece and then I'll do the next piece inside. I would keep going until I got to the end. It's really not that complicated, people. It's a chain. Alright, so now focus on this part. Alright, the next log inside. And I'm going to call it P. Alright, call this yellow piece P. So that means what I've really got here is log base 2 of P is equal to 1. If I rewrite this in exponent form, I bring down the base, the P and the 1 switch places, so I've got 2 to the 1 power. Why'd I put a 2? Why? Okay, I've got 2 to the 1 power is equal to P, because these switch places. Well, obviously 2 to the 1 power is just 2. So that means what I know is that P equals 2. Okay, now remember what P was. This is P right here. It's this yellow part. So in other words, P is log base 3 of x. So that means log base 3 of x equals 2. My goal is to find x. So if I once again rewrite this in exponent form, so you bring down the base and you switch the rest. Okay, so the 2 comes over here, so that's going to be x. So that's going to be 9. Alright, so 9 is the right answer. But if all you did was do, you memorized some pattern that you noticed, like, oh, looks like it just comes out to always be this to the power of this, I'm not anywhere near accepting that. Okay, I need to see your mathematical logic, not some memorized pattern. You have to show your work. Otherwise, nada. It gets nothing. Anyway, I got carried away just then. Sorry about that. X equals 9 is the point. Where's 18? Bring it to me on a platter. Graph each function using a table of values. 2 graphs should be shown. Parent function, dots only, including the A, and then the final function, including any translations. Okay. This is a log function. Alright, for log functions we start with the y values, like -2, -1, 0, 1, 2. The parent function here is y equals log base 2 of x. Alright, ignoring the shifting. To get the x values, I will use the exponent form of this. Okay, so there's my base 2. The x and the y switch sides, so I have x equals 2 to the y power. So that means to find these x's, I will do 2 to all of these powers. 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 to the second. Now this is going to be 1/4, 1/2, 1, 2, and 4. Alright, now I'm going to graph these, but this will not be the final answer. I have not done the shifting yet. Okay, 1/4 comma -2. So that's over a bit and down 2, like right there. 1/2 comma -1. So that's over into the middle and -1. 1 comma 0, over 1 up nothing. 2, 1 would be right there. And 4, 2. Alright, these 5 dots are showing me the curvature of this problem. Now, it's time for the shifting part. Alright, now this part right here, inside is always left right, and it's the opposite of what you think, so this will be right 1. Alright, this one out here means up 3. So we will go right 1, up 3 with all of these points here. Okay, what I say, right 1, up 3. So right 1, up 3. Okay, same thing, right 1, up 3. Right 1, up 3. Okay, so these blue dots are the real deal. Now the asymptote, because we shifted right 1, the asymptote will be right 1. So there's your asymptote. Clearly the graph is curving towards this asymptote in this type of a pattern. So I usually like to start from the bottom here. By the time it gets down here, it's going to be so close to the asymptote that it will appear to trace it. But in your mind, just know that the curve never really touches the asymptote. It just gets closer and closer, but never actually touches it. Okay, so your graph should look very much like that. Make sure your graph goes all the way to the edges of the grid. Yeah, so that was it for that one. So now, number 19. Same type of deal. Log function. Start with the y values. -2, -1, 0, 1, 2. Consider the parent function. Y equals log base 1/3 of x. I'm ignoring the 2 and the +4 for right now. To get these x values, rewrite this in exponent form. So that means x will equal, because I'm switching sides of the x and the y, bring down your base, so 1/3 to the y power. So that's going to get these x's for me. All I have to do is do 1/3 to all of the y powers. So 1/3 to the -2, 1/3 to the -1, 1/3 to the 0, 1/3 to the 1, and 1/3 squared. Now a negative power is going to make the reciprocal. So this would be like 3, alright, 3 over 1, or just 3, with a +2 power. Obviously that's 9. Reciprocal, that's 3. That's 1. That's 1/3. That's 1/9. Okay? This time there is an a value. So I need to go ahead and handle my a value by multiplying by the a value, all the y values. So multiplying by 2. So this will be -4, -2, 0, 2, and 4. Once you have that third column, forget about the second column. It's history. So let's graph these points, but this is not the final answer. We still have not done the +4. It's the one thing we haven't done yet. So these will be temporary points, which for some reason I like to do in green. Okay, so 9 comma negative 4. So there's 9 comma negative 4. And then we've got 3 negative 2. Be right there. 1 comma 0. 1/3 comma 2. Alright, so that'll be about there. And then 1/9 comma 4. Well, 1/9 is so small that it pretty much appears to be on the line. And there it is. Alright, this graph is approaching an asymptote of 0. Don't connect the dots because we're moving on. It's time to do the plus 4. Of course, this plus 4 means for us to go up 4. Oh, what am I? Yeah, I didn't mean that at all. Inside the parentheses is your left-right motion, and it's the opposite of what you would normally think. So this plus 4 tells us to go left 4. All right, I fell asleep for a microsecond there. Good thing I'm not driving. So I'm just going to take all of these points and move them left 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. Alright, now these will be the actual points. Now the asymptote, which usually is the y-axis, will also be shifted left 4. Alright, so you can see that the graph is curving upwards toward the asymptote. So I need to start from the edge of the graph, and on this end it's going to appear to trace the asymptote even though we know it never actually touches. Okay, so your graph should look very much like that. Please make sure your graph travels all the way to the edges of your grid. So there's number 19. That's it. Done. Done and done. Now, let's see. Fill in the following information for problem number 18. That's this one. Okay, the domain. The domain is how far it goes left to right. Hey, my mom's calling me, y'all. No, I didn't miss it. Alright, I'm back. That was my mom. Where was I? Domain. I think we were doing this one. Domain goes left to right. So that's 1 to infinity. Range goes bottom to top. So this graph goes from negative infinity to positive infinity. Let's see. The asymptote. The asymptote is here at positive 1. Vertical lines are always x equals, so x equals 1. You have to put x or it's wrong. Increasing or decreasing. This is going up, up, and away as we go to the right, so that is definitely increasing. Alright, so that's number 20. Number 21. Write a logarithmic function that has been reflected over the x-axis and has a vertical asymptote of x equals negative 2. Well, reflected over the x-axis. Well, first of all, a log function. Here's a nice parent function. We'll just say log x. Now, if it's going to be reflected over the x-axis, that means it has to have a negative sign in front. Alright? There, it's reflected over the x-axis. Now, if it has a vertical asymptote of x equals negative 2. Now, you know that a normal asymptote is at 0. So if it's suddenly over here at negative 2, that means it has been shifted left 2. So that's an indirect way of saying the graph is shifted to the left 2. Okay, so that's what this means, left 2. How do we make a shift left 2? Well, left-right motions happen inside of the parentheses, and they are the opposite of what you would normally think. So by putting a +2 in the parentheses, that actually means left 2, which would put the asymptote at -2. So there you have it. Left 2, asymptotes at -2, and negative in front is reflected over the x-axis. I guess I was supposed to put that on this line right here. Fine, I'll put it on the line. Stop complaining. Get off my back. Sheesh. Okay, there's number 21. Where is number 22? Okay, one of these word problems. Semi-annually. Right as soon as I see semi-annually, I know that we are using this formula that goes the eventual amount is the initial amount times 1 plus the rate over the compounding to the power of compounding times time. This n value, for semi-annually, that means the n is 2. You know, quarterly it would be 4, or monthly would be 12, weekly would be 52, daily would be 365. But anyway, semi-annually, that's twice a year, so n is 2. You deposit $8,000. Okay, that means this 8,000 is the initial amount. So that means it's going to go here for P. So I'll have 8,000 right there. Then I'll have 1 plus. Now the rate, I've got 3.4%, but as a decimal, that means R is going to be 0.034. Got to move the decimal point twice. Okay, that's why we need an extra 0. So that's the R value. So 0.034 over 2, because that's the n value, to the power of nt. Well, there's that same 2 again. T is time, like how many years have gone by. So you deposit in the account that earns 3.4% annual interest. Find the balance after 4 years. So there's your T right there. T is 4. So I'll put a 4 right there. Okay, so guess what? I mean, that's the answer. Because we don't have our TI-30 XS multiview on this test. So all we could do is set it up, and so that's it. Now for continuously, that's y equals pert. Okay, e to the RT power. So that means y is equal to, what was it, 8,000? I do believe. Let me check. Bam! 8,000. E is a constant like pi. It's approximately 2.72. So I'm just going to definitely leave E. We already saw that the rate was 0.034. Alright, same as before. And we already saw that time t equals 4. So again, that's it. That's all we can do right now. Again, the 8,000 goes here because that's the initial amount. Y is the balance after 4 years. We don't know it. That's what we're supposed to find. So don't put the 8,000 here. Simple. That's it. And I'm pretty sure there are only 22 problems on this test. So that's the end of this test. I hope this video was helpful. I will see you on the next video, my friends. Hey, if you're studying for recovery, which is like the only reason why I can imagine anybody watching this video, it is make it your personal mission and responsibility to make sure that you can do every single problem on this test by yourself. Not only that, but we had 3 practice tests. So, we had practice tests C, D, and E. So you need to go back and make sure, because there were problems on those tests that didn't show up on here, but they very well might be on the recovery. So don't just go by this. You need to go back to those practice tests, and there's videos for all three. So she got 4 videos now for reviews. Anyway, enough talk. Peace out.